This brief primer to chemistry introduces the atoms we and our world are made of, and shows how they bond with each other to form molecules. Atoms are given faces and bodies so that we can better remember them and understand their characteristics. First, the molecules that make up our air are presented. Then we can clearly see why carbon monoxide is poisonous and why ozone protects us from cosmic rays. Carbon dating is explained. It allows dating of objects that are many thousands of years old. In part 2, hydrocarbon fuels are presented and their reaction with oxygen is illustrated. Carbohydrates such as alcohols, sugars, and starches are explored. Other compounds such as aldehydes, ketones, ethers, peroxides, fats, soaps, acids, bases, and salts are presented. To end off with a bang, nuclear fission, atomic reactors, and nuclear bombs are explored. A proton is a positive charged mass making up the nucleus or heart of the atom. An electron is a negative charged mass 2,000 times lighter despite being 100,000 times bigger. It is like a balloon. An unpaired electron likes to pair up with other unpaired electrons to form a paired electron. Unpaired electrons are like arms, while paired electrons are like legs. Neutrons in the nucleus of the atom are like protons, except they do not have a charge. A free neutron outside the nucleus of an atom unrolls in about 15 minutes into a free proton, a free electron, and a spray of high energy rays. People and nature are made of atoms, so we can easily imagine atoms behaving like people. Like people, atoms have unique shapes and characteristics. Like people, atoms bond with other atoms. Hydrogen is the most abundant element, forming almost 75% of the universe. Helium forms nearly 25%. Hydrogen is the smallest atom and easily loses its proton, becoming charged. In the sun, hydrogen atoms are fused together to form all the other atoms. On Earth, hydrogen forms bonds with its one and only unpaired electron with most other types of atoms to form many types of molecules. Molecules with hydrogen form a very gentle bond with other molecules with hydrogen called the hydrogen bond. It is what holds water together in a drop. Because hydrogen is like a baby, it has a baby's face. Carbon is the third most abundant element in the universe. It is found in nature in its free form as diamond, graphite, and coal. Its two unpaired electrons, like hands, form gentle bonds with most other types of atoms. Its two paired electrons give it a very symmetric tetrahedral shape. It forms chains with other carbon atoms that are the backbone of all life. Hydrogen is very attracted to it. Because carbon is like a woman, it has a woman's face. Nitrogen is the fourth most abundant atom in the universe. It makes up nearly 80% of the air we breathe. Its three unpaired electrons form bonds that tie two-dimensional carbon chains into three-dimensional proteins and give the twist to DNA. Its three unpaired electrons make very tight bonds that are explosive when broken, especially in bombs. Used as well in fertilizer, nitrogen is very flexible, like an acrobat. Oxygen is the fifth most abundant atom in the universe. It makes up nearly 20% of the air we breathe. Its two unpaired electrons, like hands, can burn and tear molecules apart and also tie atoms together, forming tight bonds. It bonds with hydrogen to make water and then with metals to rust them. Because oxygen is like a fireman or like a policeman, it has a man's face. Metals have one or more very loosely held unpaired electrons. They are loosely held by the atom because they are crowded out by the many paired electrons that metal atoms have. When electrons break away, they leave a positive charged metal ion swimming in a negatively charged sea of electrons. Electricity is when the sea of electrons move in a direction like a swarm of bees. Metal atoms are like bees that too easily lose their stinger. Halogens have one very tightly held unpaired electron which forms very tight bonds with other atoms. Halogens are very poisonous because of their activity. Because of their attracting powers, they are like attractive flowers. Atoms, like people, form bonds with each other. Holding another atom with one hand is a single bond. With two hands is a double bond. The strongest grip is a triple bond, which would be like holding on with hands and feet. Carbon monoxide is an invisible molecule given off in the air when carbon products are partially burned. It is deadly to humans when they breathe it in. Oxygen molecule is 20% of the air we need to breathe to live. Can you now see why carbon monoxide is deadly while oxygen molecule is life-sustaining? Nitrogen molecule is 80% of the air we breathe. While oxygen and nitrogen have a similar shape, ozone, the oxygen molecule that shields life on Earth from cosmic rays, has a different shape. Can you see why it shields us? When a nitrogen atom in the air is unexpectedly hit by a cosmic ray in the right place, it coils up one of its electrons and one of its protons into a nucleus. The wounded nitrogen then looks just like a carbon and masquerades as a carbon isotope called C14, but not forever. Eventually, the very same neutron that got rolled up by that cosmic ray unrolls. The time is determined by C14's half-life decay rate. That is the time for half of all the atoms to decay back into nitrogen atoms. C14 atoms integrate into living material as long as the material is alive. When the material dies, the number of unstable C14 atoms for every normal stable C atom is known. After it dies, the C14 starts to decay. At C14's half-life of 5,730 years, half of all the C14 have already decayed back into nitrogen atoms. The remaining half needs another half-life of 5,730 years. After each 5,730 interval years, half of the C14s decay back into nitrogen.